All right, let's look at an identity verification that requires a good bit of algebra as well as just understanding the trig identities. The identity you wish to verify is the quotient cotangent 3 theta minus tangent 3 theta divided by sine 3 theta plus cosine 3 theta actually does equal cosecant 3 theta minus secant 3 theta. Now, as I've commented before, the natural thing to do if you were doing this without having to fit a certain set of symbols into a box is to start with the most complicated side of the identity and try to work on it. And the first thing I see if I were doing this out by hand is that cotangent and tangent could be related to their sine and cosine counterparts. Most notably, cotangent is cosine 3 theta divided by sine 3 theta, while tangent in the numerator is sine 3 theta divided by cosine 3 theta. So those are pretty natural substitutions for us from the identity list here and here. That takes care of this guy and this guy. Okay, where to go from here? Well, if I were doing this, by hand, I would notice that the numerator has a common denominator of sine 3 theta, cosine 3 theta. So I would have to give each one the other guy's multiplication in the numerator, and so I would end up with cosine squared 3 theta minus sine squared 3 theta when I got the common denominator. So it would make sense that what goes here is sine squared 3 theta. Now, here's where you need to be careful. Almost everyone I know would be tempted to go, oh, that's 1. No, actually it's not. It is only when it's sine squared 3 theta plus cosine squared 3 theta would it be 1. Now, in my opinion, you have a couple of options you could do here, but of course, we're trying to fit the box below. So what I want you to notice in algebra to achieve what they have here is that if you have a difference of squares, then we know how to factor that into a product of conjugates. So cosine squared 3 theta minus sine squared 3 theta would factor as cosine to the first 3 theta plus sine to the first times, its conjugate. So that would be cosine 3 theta minus sine 3 theta. Okay? Now what in the world happens? Okay, well it's factored, but I see that between the numerator and the denominator, addition is commutative. So this term is exactly the same as this term. Therefore, they cancel. Okay? And if they cancel, then you're left with this. Over this. So cosine 3 theta minus sine 3 theta divided by sine 3 theta cosine 3 theta. So how are they getting this second box? Well, notice that the cosine term is broken off. So if I were to also break off the sine term to split it up into two individual pieces, notice when I do that, something happens with this second piece that I get a little cancellation going, left with a 1 in the numerator. So what we would have here is 1 over cosine 3 theta. What would have also happened here was cancellation, and you would have 1 over sine 3 theta minus 1 over cosine 3 theta, or cosecant 3 theta minus secant 3 theta. Now guys, these take practice, and again, I suggest that you take the left-hand side and you try it on your own, using your own steps and creativity, and see if you can get to the same place. That is excellent practice for verifying identities. And then of course you can come back to these where you have to work within the strict parameters of what to put in the boxes.